Hi everyone, welcome back to ShortGATE. Today we are going to continue our gate preparation by learning another essential sorting algorithm, that is insertion sort. This algorithm is quite efficient for smaller datasets and often come in both theory and practical questions. Let's dive into how it works and why it's important. Now see, what is insertion sort? Insertion sort is a comparison based algorithm that builds the sorted list one element at a time by comparing the current element with the already sorted portion and inserting it in the correct position. It's efficient for small or nearly sorted datasets and often used in practice for such cases. Now see how insertion sort works. Start with the second element. Since the first element is already considered sorted, compare the element with the previous elements in the sorted portion. Shift the large elements one position to the right to make space. Insert the current element in its correct position. Repeat for the entire array until the list is fully sorted. Now see an example. Let's sort the array 23, 1, 10, 5 and 2 using insertion sort. The first two elements 23 and 1 are compared and 1 is inserted before 23. Then compare 10 with the sorted portion 1 and 23. Insert 10 between 1 and 23. Then insert 5 between 1 and 10. Now insert 2 between 1 and 5. Then the list is already sorted. Now see what is the time complexity. The best case time complexity is order of n. Happens when the array is already sorted. And the worst and average case time complexity is order of n square when the array is in reverse order or unsorted. Now see the disadvantages and advantages of insertion sort. What are the advantages? It is simple to implement and easy to understand, efficient for small datasets and nearly sorted array, requires less memory in place of sorting. What are the disadvantages? Inefficient for large datasets due to order of n square time complexity. Slower compared to more advanced sorting algorithms like merge sort or quick sort. Now here is the code for insertion sort. This code sort an array using the insertion sort algorithm. It starts from the second element, compares it with the sorted portion and shifts larger element to insert the current element in the correct position. I hope this explanation of insertion sorts was helpful for your gate preparation. Don't forget to like and subscribe. Comment with any questions or topics you would like me to cover next. Thanks for watching. Keep practicing and comparing sorting algorithms like bubble sort, selection sort and insertion sort to get a better grasp of their strengths and weaknesses. We will cover more important algorithms in future videos. Until next time, happy learning and let's crack gate together.